Hey folks, we're about to kick this off in a minute. Make sure this works. All right. You know, hang out over there, grab a seat. Come on up here. Welcome to the afternoon block. I will be your host. I'm Nick Steele. Hello. I also happen to be running this talk with Rene about trying to get rid of insecure import, export, and exchange and sharing of credentials in credential managers like ourselves at 1Password. So this is Rene.
Yeah, so I'm Rene Leveille. I'm a developer at 1Password, and Nick Steele, he's just...
And I'm Nick Steele. I'm just a guy. Now, I'm a product manager at 1Password. I've been involved in FIDO for, 8 years now. But when I came over to 1Password, we kind of started working on a really fun problem with our friends over at Dashlane with Rue Islam and his team, right there, on how we can get out of a real just kind of like problematic situation with credentials. So we'll talk about how we got here and what we're doing now with Credential Exchange. And you may have heard of Credential Exchange. We just had an announcement today, this morning, about what Credential Exchange protocol is doing, where it lives. It lives in FIDO. There's a Wired article about it. Very cool. And we're going to give a demonstration of what Credential Exchange could look like in use for developers and end users of our apps. And we'll talk a little bit about what's next. So how did we get here? What's the issue? Well, the current state of sharing credentials, exchanging credentials between different services is non-existent. Generally, if you share passwords across different password managing apps today, the trick is to copy pasta your password and then put it right into your importing provider. And that's not great for many reasons. One being you now have moved the credential out of the boundary of this provider. And once you get the credential over there, assuming it is in the proper format, it may not be accepted by that provider. Now, migration is even worse. It is truly heinous, but we are not one to speak, about it. We as a collective industry all do the same thing when we talk about how these credentials get moved. This is a true and serious crime. I've protected the identities of these two password managers. But the way we migrate between these providers is a unformatted and unencrypted CSV. Sometimes we call it something slightly different, but generally this is how it works. I think 1Password calls it a 1PUX file. But for the most part, this CSV, more importantly than unencrypted, is unformatted. So everyone has to have their own way to parse the CSV of an importing provider when we see new keys. How do you share passkeys today? Well, that's the fucking deep part, you don't. So today there's only, I think, 2 other credential managers that actually allow for passkeys to get moved. But the problem with that is, well, now we're kind of breaking the guarantees, the security guarantees of passkeys, right? We're moving clear text private keys, which is a bit of a no-no. But we're getting there. Although this year we've been getting there a bit slowly. So earlier this year, this is a slide we put together. We've seen a lot of different articles, diatribes, manifestos, blog posts from many different people talking about why vendors love to lock users in and why we can't move passkeys today. And the issue is, we don't want to lock people in. We want people to be able to move around. We want passkeys to be portable, but we want people to do this safely. So about a year ago, Rue and I and our collective teams at 1Password started talking about credential exchange. And it's amazing that this happened only about a year and a half ago in standards time. This is actually a pretty short period. As I said, FIDO 8 years. It takes a while. So being able to get something out of the door this quick is really impressive. So I'm happy to pass this over to Rene, who'll talk more about what we did.
All right. Thanks, Nick. So what is Credential Exchange? It's essentially a family of specs that you have a format, which is a standardized JSON object, and the protocol. The format itself has been made through a lot of research, collaboration from many different credential providers here at FIDO. So we could find anything that was all of the credentials, all the commonalities between credentials that we all hold, and put that in a well-defined JSON object. So this, there we go, okay. This object has a header just for general metadata. It has information about the user account, the items in that user account, along with one or many credentials, and has the folder, the user's folder or vault structure. We call them collections. And most importantly, like I said, these are all things that contain commonalities between all the credential providers. So it's fairly bare bones, but every provider will hold extra information. So they're all extendable. And so this format can be used to export passkeys. But it would really suck if you had to export passkeys in one way and then all your other stuff in another way. So we support passwords, TOTPs, addresses, files, driver's licenses, credit cards, notes, SSH keys, and we can add more. And many providers also allow you to share between family members or team members if you're in an enterprise. So we also have a way to model sharing between users, specific users or groups of users directly in that format. So you can migrate to a different provider and know that the sharing structure that you've painstakingly gone through is still there in that other provider. So here we have a little example of the format itself. This is the clear text. So we have a version number, we have the exporter in the header. An export could have one or many accounts. Each account will have a unique ID, the collections, which is the vault structure, as I mentioned earlier, list of items, and the extensions. So that's where provider could just dump a bunch of extra stuff. In the items, each item, again, has a specific ID, the extensions, and a list of credentials. So for the credentials, on the right, we have passwords, which, unsurprisingly, URL, username, password, standard stuff. It also allows you to, if the user edited the label, you can transfer that over as well. It's fairly common. You'll see that in the CSV, the cursed CSV that Nick talked about. But now we also have a standardized passkey format, which hasn't existed yet. We have the fields enumerated in WebAuthn and FIDO, but it hasn't really been standardized as to how we transfer this into like a JSON format. Now we do. So you have the key ID, the RP ID, and if that passkey has specific FIDO2 or WebAuthn extensions, it can travel with those that extension metadata. So say you have PRF in one provider, the PRF credentials will also be transferred over with that passkey. So this is great, but that's still unencrypted. And so we have the protocol, which is the second spec that handles the encryption. We base this on hybrid public key exchange, which is a new spec in the IETF. It's basically Diffie-Hellman in the most case. So you share your keys and derive a shared secret. So in the actual protocol, you have the importer and an exporter. The importer requests an export, so it'll generate their key pair, send the public key to the exporter, and the exporter can accept, deny, whatever. If they accept, they'll generate their own key pair, derive the secret key, build that JSON structure, and encrypt it with that secret key from HPKE. They'll then send back the public key and that encrypted blob so that the importer can derive the secret as well and decrypt the key. Decrypt the credentials, so they have access to all of the credentials that have been exchanged. And this is very important since this allows the passkeys and all the other credentials to never leave an unencrypted boundary. So they're always encrypted in transit within the boundary of the provider. Outside of that, can't have access to them. Another important factor of the protocol, if this wants to slide, there we go, is it's configurable. So say you have the importer only supports passwords and passkeys, which many do, and then the exporter supports many other credential types. Well, you don't really want to export everything. You just want passwords and passkeys. So you can specify that in the protocol. Like that, the exporter can ignore everything else and just send over those credentials that were requested. Those other credentials stay in the exporter's boundary and never get shared with that other provider. So back in May, we've partnered up with Google, Dashlane, Bitwarden, and NordPass to create a demonstration of this. And we've got a video here, if we can roll it. Does it work? Oh, that's the other demo. No, OK. Unfortunately, the videos aren't working. But essentially, you have in the demonstration, you can come talk to me afterwards. I can show you the video. You have 1Password exporting to Dashlane, creating a passkey in 1Password, and demonstrating that same passkey working in Dashlane using an API that Google provided us on Android. And it also works across devices through the hybrid flow. So if you're used to using a QR code to sign in with a passkey, that same flow could be used for credential exchange, where you have a standard way to exchange credentials across devices and also across platforms, across ecosystems. So what's next? Well, we have the bulk import and export case figured out, and we're still finishing that up. But we could also use this to share specific credentials between users of different providers. So say you really want to just share your Wi-Fi or your Netflix account with your uncle who's using a different provider than you. You can share this securely between the different providers. Or say in an enterprise use case, you have a document that you have to get another company to sign. You can share this through this protocol as well. So it never ends up being unencrypted through email if that's if it's a sensitive document. We could use this as an encrypted backup. So if you back up using a standard format, if, say, you have a cloud provider that goes under, and you have a backup of that cloud provider, you could import that back into a new provider that supports the format, and you're good to go. They don't have to implement that old provider's specific format as CSV. They just have to implement this spec, and you're recovered. And finally, there are use cases for verifiable credential presentations. We're not really sure how this is going to work out, but we're pretty confident that we can include verifiable credentials in the flow. That's because, in most cases, we were talking about an importer and exporter, but there's actually a third party here. The importer and exporter aren't people, they're providers. And so you have a third party, the authorizing party, who's generally you. You're the one authorizing that 1Password is importing or exporting from Google, and you're the one that's orchestrating the flow and authorizing it. But you also have a case where it could be a business. So if you have, again, exchanging between different providers or different businesses, you can exact policy directly on what's being exchanged with what provider you're exchanging it. What can you export to different providers or different other businesses? And in the case of verifiable credentials, you're going to have the issuer, most likely the government, that'll be in the flow. You can exchange some form of proof that the user wants to migrate to the importer, and you have to have that issuer in the flow to be able to provide the verifiable credential presentation. The presentation itself might not move, but you can do some form of proof including the issuer together. So where we're at currently, as Nick mentioned, we've had a press announcement about our working drafts currently. A new working draft will be coming out on this Friday. And you can think of working draft as a alpha. There can be many breaking changes. It's not super stable. That's why we're going to try to get a review draft, which is kind of like a beta, by the end of Q1 next year. Going to try. It's fast-paced for specs, but it's not impossible. And then eventually, we don't really have a plan for when this will happen. You'll have a proposed spec, which is the finalized specification in order to get full implementations outside in the wild. You can still have implementations in the review draft, but it's not super recommended to have implementations during the working draft stage. Finally, I want to have a huge thanks to all of these companies and their representatives who have contributed and committed to this specification. This could not have been done without any of them. And also, it's a huge collaboration efforts between direct competitors. Finally, we also want your feedback. So if you're a provider that is not part of FIDO, you can still give feedback on the spec. Please do go to this GitHub website or scan this QR code. It brings you there. And you have links to the specifications directly. Read them, give us feedbacks, create issues. Your feedback will be taken into consideration when we're developing the specification. We want this to be available to everyone, including outside of FIDO. This is not a walled garden. We want this as open as possible. And I think we have a few minutes for questions. Thank you.
Good stuff, my man. You're live.
Yes.
Hello, one. Okay. Hi. So say I've been using an insecure password manager for like a lot of passwords or passkeys already have in there. They had a leak. Now I want to migrate to a secure one. If I understood you correctly, then you're just like migrating the passkeys over, so my passkeys would still be compromised. You're not like creating new passkeys with a relying party and like disabling the old ones or something like that.
No, indeed. It will be the same passkeys. They don't get changed. They don't get, there isn't any difference. So they would be the same key material. It would still be up to the user to go into those websites and change the passkeys.
Are there like any efforts in FIDO org to automate that process? Like go through all my passkeys, recreate them all, or like?
That would be close to federation. So currently that's kind of a sticking point with that. There's no real plans to do any automated change. Although if you've seen Matt Miller's talk, there are new APIs coming out to signal that the passkeys may have been revoked by the website. So in those cases, you'll have the ID of the credential. It might not be acceptable by the website for that user account anymore, and then you'll go through that flow.
Thanks.
Just a follow on the similar question. So in this case of passkey credential exchange from A to B, are you expecting the relying parties to basically handle things like, I'm expecting the AA GUID is going to change from the previous passkey to the new one, or what's the general recommendation around that?
Yeah, so the AA GUID would change. In fact, we see that as like a good signal for the RP, especially if they want to perform some additional step-up authentication or other risk assessment alongside the passkey when the provider changes. We also have been working on a set of like trust signal statements that we can give to high assurance RPs, and this would be included in that information, right? That the credential has been imported or exported or moved to a new spot, because we see that as a sort of like a valuable trust signal. So you're right. It would change, and that would be reflected if you were to query the AA GUID from in the request. Yeah.
Just one follow-on. The trust signal that you mentioned, is it going to be part of any WebAuthn specifications?
No, that's a lot of that work is still early days. I think we're still trying to hammer out the solution in some of the technical working groups, and then from there it'll probably live as a extension. So we would figure out how to draft it in W3C or here. But yeah, that work is on the way.
Thank you.
Any other questions? I'm going to check online. No, Apple is on one of the early adopter lists. Thank you, Shane, for your helpful comments. Well, that's all we got.
Cool.
Big ups to Rene. Great job.